Question with elastic string, and you should think at this point about using Hooke's law. So we've got this string here, so it's been stretched, so there's going to be tension in both parts of the string, equal tension. Given lots of info, we've got to show that the modulus of elasticity is this. It is in equilibrium to a distance of 2L. Right, so what do we know? Well, we know using Hooke's law that tension is going to be lambda x over L, where x is the extension, L is the natural length. So that means our tension is lambda. Right, we need to know the extension, so you can do a bit of Pythagoras to find out that this side here is 2.5L, which makes the total length of the string 5L, and the natural length is 3L, so that's obviously 2L. Right, natural length of the string is 3L, so tension is 2/3 lambda. Now it's in equilibrium, so this is hanging down if you check the question. So reacting down, we've got the weight, so we know that the weight must be equal to the components of tension acting in the same direction. So in the same direction, we've got two lots of tension. If you look at one side, you've got tension, and if I just call that angle there alpha, then I need to do cos alpha to get 1 t cos alpha is the component of from one tension, and 2t cos alpha is 2. If you use this angle here, you'll be using sine instead. Right, so mg is 2 times tension, and then cos alpha, well, that's going to be 2 over 2.5. If we work all that out, we get that mg is 16 over 15 times lambda. Therefore, lambda is 15 mg over 16, which is what they wanted you to find. Right, so now it's going to do something else. So now the particle's pulled downwards. Okay, that's fine. Until the total length. So here we go. This particle B, the total length is 7.8L, so that means this side is 3.9L. This distance here is still 3L, and you can use a bit of Pythagoras to find out that distance there is 3.6L. Okay, still got weight, still got some tension in the string. It's then released from rest, and we got to show that P comes to instantaneous rest on the line AB. So if I call this point here C, for example, which is where it is now, one way we can do this is to look at energy. So I've got point C, which is the start, and the line AB. What sorts of energy have I got going on? Well, kinetic energy, gravitational potential energy, and elastic potential energy. So at the start it's released from rest, so kinetic energy is 0. Although it says it comes to instantaneous rest on the line AB, we want to show this, so I'm going to say that the kinetic energy at AB is half mv squared, where v is the speed when it crosses the line AB. We're going to set gravitational potential to be 0 at the bottom, so mgh, now I've worked that out in my triangle, 3.6L. Elastic potential energy. So the formula for elastic potential energy that you need to learn is lambda x squared over 2L. So we know that lambda is 15 over 16 mg. The extension, so it's now 7.8 long, and the natural length was 3L, so that's 4.8L. Okay, over 2 times the natural length, which is 3L. Now, when it crosses the line AB, the extension is 0, so there is 0 elastic potential energy. Therefore, using the work energy principle, at point C, we've got our elastic potential energy here. So elastic potential energy at C has got to be equal to the kinetic energy at AB plus the gravitational potential energy at AB. There's no other forces to do any work going on here. So you can write all this in and do some simplifying. Okay, so as we can see now, this means that V must be equal to 0, and so it comes to instantaneous rest. Remember to write conclusion. Okay, so remember your conclusion at the end. Do bear in mind all the assumptions we've made along here. So you might have had to, we've made assumptions it's a particle. Imagine it was a situation where there was a ball crossing the line. You could talk about the fact that the ball has size and won't be a particle, so where it crosses the line might not be very well defined. You could talk about other assumptions potentially like air resistance, no other forces acting and things like that. So sometimes they ask you what assumptions you've made and how they could affect your result.